Hello, I'm Eric Snodgrass, and thank you for watching today's long-range technical forecast video brought to you by Nutrien Ag Solutions. This analysis is being provided for perspective only, and any decision made based upon this presentation is the sole responsibility of the person making the decision. Finally, please remember that all long-range weather forecasting is speculative by nature. Well, I wanted to catch us up on a few things we've been discussing lately. First is a great satellite animation here, or image from yesterday, once again showing us the extent of that dust plume, and I'm excited to see how this all kind of unfolds again today as we get some new imagery in from our high-resolution satellites. The space station grabbed a beautiful view of it as well, and this is extensive dust. And as we've been discussing in the longer term, this could possibly be one of the things that impacts the frequency of tropical cyclones later on in the season should dust like this continue. But I've got a lot of work to do to try to understand what controls that Saharan dust plume as we work our way throughout a particular hurricane season. I want to thank David for posting this for all of us to see, just to show you how much the air quality had degraded in some places. This is from Puerto Rico, showing you what it looks like to see the really dusty skies there. And also had to pull this into the video today too. This was on Cuba. So even through all that dusty air, still got a big powerful thunderstorm that popped up here, kind of orographic lift there on some of the higher elevation in the middle of Cuba, just blowing up into this huge thunderstorm. So I thought you might like to see that. Okay, as we work our way through the next 5 days, this is how the dust plume is moving. And so we can see that as we work our way into the weekend, it'll be fully across the southern United States and then pushing into actually parts of the Mid-South, the Corn Belt, getting even into the Northeast. And so what you can expect out of this is some hazy skies, some pretty brilliant sunsets, and also if it does rain and when it rains and the rain evaporates, you're going to get like a dusty red film on vehicles and things like that. And you'll be able to see it. Wipe it off with your finger. It'd be kind of neat for you to do that. Let's check on some other things that I have presented recently that I can give you a quick update on. The map you're now looking at is cumulative downward solar flux. So again, we're looking at how much sunlight has hit the ground. And I've got a little bit longer time period over which this analysis is done. So this is going back from May the 1st all the way through the 23rd of June. And once again, because of the deficits we picked up in May here and some recent heavy rainfall in that area, we can see it's been quite cloudy inside of that first circle that I drew there in the heart of the Corn Belt. Then as you get over here toward the Carolinas, same thing as well in parts of the Mid-South to the Appalachian Mountains. A lot of sun down here in Texas and Oklahoma, as well as this part of North Dakota and the southern parts of Manitoba and Saskatchewan. And that's kind of where we do have some drought in this area. I'll show you that in a few moments here. But just to overall take a good look at where we've seen excessive sun and where we've seen a lot of clouds. It's kind of an important thing to think about how quickly this crop is progressing. I just want to also illustrate that over that same time period, look at much of China's growing area showing up very cloudy, and in and around the Black Sea. Notice we've had that same issue there as well. So a few things to be looking at here globally as we think about cumulative downward solar flux. Another thing I want to catch you up on, again, I've just updated this map. March 1st through June 22nd precipitation, comparing it to 2019. So I think it's interesting to look at this map and see that we do have a big section here of parts of Iowa, Wisconsin, and even parts of Minnesota that are showing up on the wetter side of things in 2020 than we were in 19. But clearly in the Central Plains, extremely wet. Over here in this part of the Eastern Corn Belt, extremely wet. But look down here in parts of the Mid-South, getting down into the Southeast. 2020 has been a much, much wetter year, which we've been kind of reporting on here. Here's another neat way to look at this. What you've got now is May 1st through June 24th, looking at climate division precipitation ranks. So the number that's in each climate division kind of tells you where we currently stand this year on the 128-year record. So very wet in the Pacific Northwest. You can see some of the dryness I was telling you about in parts of North Dakota, northern Minnesota as well. We've been talking extensively about the dryness that's coming out of the Four Corner states into parts of western Kansas, Oklahoma, and Texas. But overall, you get east of there, with the exception of some places in the Northeast, things have been, on the whole, near average to wetter than average, and very wet over North Carolina where that upper level trough sat last week. Now, to compare this to a year ago, take a look at this calculated soil moisture anomaly map. And I've shown you this a few times, but let's just go back to it again. Because when we thought about what happened last year, when we think about what happened last year, when the heat did come on later in the year and the dryness, remember we end up having drought develop in parts of Illinois and Iowa, and then later in the year farther to the south of that. Well, one of the things that happens when you have this much moisture in the soil is when the sun beats down on it, remember, half of the sun's energy goes into evaporating water, which means if we started off dry, our chances of getting much, much hotter are increased. If you start off moist in the soil, Remember, half of the energy has to go into evaporating the water before it can be translated into what we call sensible heat. So why I'm telling you this is take a look at last year and now look at this year. So this is through June 22nd. Again, we can see the impacts of Cristobal. We can see the impacts of the recent heavy rainfall in the Carolinas, but we do know we're dry in this area. Now in the coming forecast, we are wet in through here, and that will sweep through the eastern Corn Belt. We're wet coming through this part of Texas, getting into the Cotton Belt. But there will be a narrow corridor in the middle that will be seeing some drier conditions. Nothing has really eliminated my concern about the high plains and central plains drought possible, getting worse throughout the growing season. But the question is, how far to the east does it get? Now, when you look over the last 7 days, we've had some very, very wet conditions, and one would be tempted when looking at a map like this to think that just everybody got rain. But I know that a lot of you didn't, and I want to make a point here by removing every location that has seen less than an inch. So you ready? These are the places that got less than an inch of rainfall. So my concern areas, let's start north, work our way south, and then east. This area and through here. If we see drought expansion here and in the Canadian prairies, typically that's not relieved later in the summer. We're going to watch it carefully. Notice in parts of western Nebraska, getting rid of Colorado, a lot of places in here missing. We can see a hole in this part of southwestern Iowa, and then the much larger one kind of centered right there on Kansas City that extends over into eastern Kansas and also into Oklahoma as well as Arkansas. There are places in the eastern Corn Belt that missed out on almost all of this, and it's patchy across the Cotton Belt. But the rain that came through here was much needed. In some places got quite a bit of it. And a big chunk of the Corn Belt did receive a lot of great rainfall. So we have to take the good and the bad together here as we look forward in this forecast. Current calculated soil moisture anomalies. Look at how much we've lost inside of that hole around Kansas City. And even though we made up some recently over here in the eastern Corn Belt, there's still overall deficit. And like I said, storms coming in here and also coming around like this in the near term. So we're going to watch this map evolve and change. But another way to look at it is just looking at the last 14 days of precipitation expressed as a percent of normal. And the things that kind of jump out at me are these corridors right in through here that are dry, as is parts of the Northeast and parts of the Cotton Belt. So let's keep an eye on this as we progress forward, because there's patchy drought across the country, and some places have had so much rain they wish they could give it to others. When we look at our root zone soil moisture, this is a drought indicator. Again, I want to come back to that point that any potential heat that builds into this section of the United States is going to first have to overcome the fact that there is, across a broad sector there, decent soil moisture. So if the heat comes on, remember, we got to evaporate water first before we can really pound the heat into the ground and get the temperatures way up in the triple-digit range. Keep that in mind as I show you this temperature forecast in a few moments. First, the next week's worth of rainfall. Again, remember the two corridors that I pointed as being wet here and through here. Remember that when you look at this, I put a hard contour at a 1/2 inch and another one at 1.5 inches. So we're going to watch out for some stormy conditions that are brewing right now in the central Canadian prairies that will get down through here toward the end of the week and weekend. And then we're watching a plume of moisture that's going to cut from eastern Texas all the way over to the Carolinas. But there are places, see this wedge in here, that's going to get missed, drier in the Northeast as well. And what's typical of this time of year is the drier conditions out west. Putting it all and comparing it to normal, now you can see that showing up a little bit better in there, plus where we're expecting a lot of thunderstorm activity in week 1. So let's go from there and talk about the pattern, because by the time we get to early next week, we are seeing what looks like an omega pattern. It's not blocked, but there's an omega pattern there. And this trough is going to come through and really cool off the west coast after what has been this week a very hot week. But our ridge is going to be oriented like this through the Great Lakes states up into parts of the Hudson Bay. And I want to talk to you in a few moments about what the orientation of that ridge might mean for us. So let's go from there all the way out to day 10. And this is what we see. That's the pattern. With the high pressure cell here in the upper levels and the ridge axis, let me just draw a line on it going something like that. Now this trough that's sweeping in over here, do you see this broad trough? I'll circle it again along the East Coast, is critical. And this is why. If we were to go over in the midsection and eastern half of the United States to really hot and dry, what would end up needing to occur is the trough would have to be here and the ridge would have to be oriented like this. That is the better orientation to put down a big area of higher pressure here, which cuts off the Gulf of Mexico. But I'm going to erase it so that you know we don't have that forming just yet. Instead, this makes for very active weather in the north central plains and the Canadian prairies, and moisture builds up into it, and we're going to see mesoscale convective systems, storms plowing through that moisture, I think. So we're going to have to watch that very carefully. It's not truly just yet a northwest flow situation, but as the heat moisture build in, I don't see this thing shutting down. So what I have for you next here, this is the week 2 precipitation anomalies. And we really see those corridors showing up as active, right? And it's right in through here. You can see it showing up very well in this forecast. So I have the European on the right and the GFS over there on the left. And I'll tell you, this place in through here that you're seeing showing up dry, we will still be getting thunderstorms inside that area. It is not going to be bone dry. There will be thunderstorms in there, but that is the nature of thunderstorms, right? They're hit or miss. So let's talk temperatures. I'm going to animate for you the next 7 days. And what you're going to notice is that heat that's out west breaks down and the above average temperatures go racing toward the Great Lakes states. As we look out there into week, the 6 to 10 day, now that fully amplified pattern shows up, and look at the the heat transport we're going to be getting up into this area. Same thing showing up in the European model as well. And going out to day 11 through 15, you might be saying, wow, with such a sizable ridge going here, why not the excessive heat in this area? There's a couple of reasons for that. First, this is the hottest time of year. So to be hotter than normal during the hottest time of year, that's difficult. Secondly, we've got decent soil moisture in some of this area, which again comes back to the idea of you got to evaporate that water first, and I'm extending that up a little bit farther to the north. So what does this look like? Well, this is going to be 90-degree weather extending into this area and possibly triple digits as you get down into this region, and we're certainly not slowing things down in the southwest for extreme heat. But remember, it is the hottest time of year as we work our way out to the second week of July here. Now, the second part of my presentation today comes from a question I received yesterday. You've probably heard in the news a lot lately about the extreme temperatures we've been seeing in Siberia. And over the last 23, 24 days, parts of Siberia here have been setting all-time records. In fact, in Verkhoyansk, that's a city in northern Siberia, north of the Arctic Circle, they had 100 degrees Fahrenheit. Well, I started thinking about that region right there. I put it in a square for you. And I wanted to know what kind of longer range impact this is going to have, because I got asked this specific question for us. So we know that there are a lot of fires in that area. I mean, just take a look at this image here. Active fires in Siberia, all of the smoke to the south of it. We have really, really poor air quality here because of this. Well, with the fires and the really dry conditions, we also have, with the heat, the Arctic sea ice is retreating, and it's doing it at a very quick pace. 2020 now showing the lowest extent of Arctic sea ice north of Siberia. So if we're warming that part of the world up, what does it mean? So here we go. Let's get into the weeds, all right? What I did was I went out and I found in June all of the years, there they are, where we had extreme heat here. Very noticeable extreme heat. And then I wanted to know what happened in the July that followed. It's an analog approach, okay? What we're looking at first here is the zonal, which means west to east flowing winds in the jet stream. The first thing I noticed is things slowed down here and here, and the jet stream retreated to the north. Now that makes sense, right? If you weaken the northward temperature gradient, the jet stream goes with it, goes into Canada. It moves north. That's a critical piece to this. Secondly, what did it do to the 500 millibar pattern where we look for troughs and ridges? Well, what we see coming across the North Pacific is something that did a little bit like this. So I kind of traced out what we saw. So there's a ridge here and a ridge there and another big ridge going up into Greenland, troughing over this part of Europe, troughing that's happening here where we had the heat, troughing that's happening over this part of Europe as well. And I want to show you something. Are you ready? When we see that as what happened during the Julys that followed those super hot years in June for Siberia, well, take a look at this and compare it to the forecast. This trough, and this trough are all here. See them? 1, 2, and 3. Next, you see the ridges here, the jet stream coming over like this and running up into Greenland. That is almost exactly what we're seeing in this place. So the northward retreat of that jet stream. But the question is, does it slow down? As it moves north, if a trough is located here and there's a ridge to the south, the jet stream gets fired in between the two things. So I don't see what I would worry most about of having a slow jet stream, one that could block up here in Alaska or Greenland. If I'm going to be wrong, and trust me, I'm wrong a lot, but if I'm going to be wrong here, it's that point. The jet stream is not going to be fast. If it is not fast, we're all going to see much drier conditions. But should it stay this way, well, this is what we end up getting with our surface temperatures. It's warm across North America. It's warm along the west coast of North America. It's cool here where it was warm. And look at Australia and South America and all of Africa and Europe. Now, let's take a look at it. These are those Julys that match those hot years in June. Ready for Siberia? Ready? This is the forecast. You can almost see the same pattern emerging. I'm circling all those same areas. And warm across North America, just like we saw during those hot Julys. So that's a really critical piece of this upcoming forecast. And take a look at this. During those years, a very noticeable warm North Pacific with kind of a budding La Niña when you kind of put all these years together. And that's kind of what we have right now, very warm North Pacific and this La Niña that's trying to get going. Now, I want to talk about that La Niña next because we've seen the ocean temperatures at times try to get down here below minus 0.5 degrees Celsius. But as they've come down back in May, they then bounced and we're currently sitting here. Now, this is Niña region 3.4, which is what I'm putting the box on. So is this La Niña actually going? Because the models suggest that we're going to hang out right here at weak La Niña territory all the way through the end of this year. We have to get way down here with colder ocean temperatures to be a full-blown La Niña, and we need the atmosphere to respond, or way up here to be an El Nino territory. Look at this, though. The Southern Oscillation Index, which I'm just going to draw a line at the 0 point here. Remember, if you're going down here, this is El Nino values below minus 7. Up here, this is La Niña values at greater than plus 7. We're currently sitting at about minus 8, which means the wind speeds and the pressure patterns in the Pacific, even though the ocean temperatures look La Niña, they're not behaving La Niña. There's a big westerly wind burst here in the forecast and another one over here by South America. Yeah, there's some strong trades in between, but this is not truly a full La Niña setup just yet, which is why I think we're prolonging the risk of getting super dry in North America. Here's what I think is controlling things. It's the MJO. Now remember, we came out of phase 3, 4, 5, 6, and 7 quickly in May, but then once it got to June, it has just been sitting here in a standing wave over Africa in phase 1 and 2. Because of that, the descending upper level air has really been over that part of the global ocean. We've actually had some rising motion over this part of North and South America getting over toward Africa. The good news is this doesn't just cap everything over this part of the world. This is not a big global squashing feature on the atmosphere in parts of North America. And here's the last piece. We're deep in the woods now, or in the weeds now, but let's just keep going here. QBO, quasi-biennial oscillation. It's a wind deep in the upper levels of the atmosphere that we watch move through an easterly and a westerly mode. It came out in 2019 with the westerly mode. It tried to go easterly, but it's going back over to westerly. So what do we get when we have a strong westerly mode? We get a jet stream pattern that does something like this. Very similar to what occurs when you have a lot of heat over Siberia. So I'm trying to put this piece together. And even though this brings in a lot of warmth through North America, it tends to keep temperatures much closer to normal along the west coast, but a very active pattern across the United States and Canadian prairies in terms of thunderstorms. And see this low pressure I'm kind of coloring over here? That's the good indicator that this whole pattern at this stage of the game today, at the end of June when I'm talking about it, isn't giving me any signals that it's just going to get locked up and locked down and super hot and dry for everybody. That's what I'm trying to show you here. So the result of all of this, yes, the jet stream has progressed to the north, but I'm not seeing any blocks. I'm forecasting hot and stormy summer, okay? Look at the jet stream pattern. I don't like what this means for the southwestern monsoon. I don't. But northwest flow coming in here is a high probability. Last few things in this video. Remember, we have seen global atmospheric angular momentum collapse, but this drop-off has been in the southern hemisphere. If this gets made worse because the northern hemisphere global winds, the northern hemisphere winds drop down too, especially in the North Pacific, everything I just told you is gone, and we're going to ridge out and have problems. But if it does come back up, or we see some increases in those winds, we're in much better shape. So it kind of boils down to this. Ready? What we see is as we get into the beginning of July, this is through July 9th, the subtropical ridge sits over here, not over like Nashville, okay? So we tend to still get tropical moisture from the Gulf coming in here, met with some converging winds out of the Canadian prairies. So right in through this area, there's a reason to see activity in terms of thunderstorms. And if you notice, if the ridge does sit here and the flow comes in like this, the winds come around the top like that in the mid-levels, and we could get some northwest flow and some thunderstorms. That's the case that I'm building right now, and that's why I tend to buy into what the European model's calling for July. And that would be warmth across much of the United States. I do believe it's too warm in terms of its bias out west, and I don't know that this area is going to be cool. But the chances of seeing a lot of thunderstorm activity inside of the area I just highlighted here, I think is elevated. So as we think about this, and I just removed those drawings, what could make me wrong are a lot of things. I think we just got to watch Alaska and Greenland most carefully to see if for some reason we build in deep troughs over both regions. If that happens, everything we just discussed is out the window. But that's why I watch it every day, and I'll report back to you if those changes occur, all right? Hope you found this instructive and informative. I appreciate the attention today. Have a great rest of your week. Thank you.